dear students. Yesterday we were discussing the Kronig Penny model and I left the lecture up to this determinant. It was the determinant which was coefficient, which was due to the coefficients of A, B, C, D, and it must become 0 for their solution. So the cofactor of this one, this is the determinant 1, 2, 3, 4 columns and 1, 2, 3, 4 rows. So if I take the cofactor of this one, then it will be minus iota alpha plus k minus beta minus iota k, then beta plus iota k. Here it will be e to the power minus iota alpha plus k into a minus e to the power minus beta minus iota k a and minus exponent beta plus iota k into a, then this minus iota alpha plus k multiplied by e to the power minus iota alpha plus k into a, so on, minus beta minus iota k e to the power minus beta minus iota k a, and the last term will be beta plus iota k exponent beta plus iota k a. This is first cofactor. Similarly, minus the second cofactor plus third cofactor and minus fourth cofactor, and these further has to be calculated with coefficient of this will the cofactor. You can open these determinants, and then I shall use these basic formulas, that e to the power iota theta plus e to the power minus iota theta upon 2 is cos theta, e to the power iota theta minus e to the power minus iota theta upon 2 is sin theta, e to the power theta plus e to the power minus theta is 2 cos hyperbolic theta, and e to the power theta minus e to the power minus theta is 2 sin hyperbolic theta. These values, these formulas I shall use after expanding these determinant. You must notice this, that we will first expand this determinant in the cofactor form, and each cofactor will be another determinant of 3 rows and 3 columns. Then further there will be we have to solve, and then we shall use these particular formulas of cosine theta and hyperbolic functions. I shall get this equation. This will be the equation which I shall get. Here it is: b square minus alpha square upon 2 alpha beta sine hyperbolic beta b sine alpha a plus cos hyperbolic beta b cos alpha is equal to cos k a plus b. Now this equation is too difficult to solve. Means if I ask you to determine the values of variables using this equation, then it is a very tough trigonometric equation to solve. So we use a simple approximation. Come to the diagram here, that of the Kronig Penny model. Here it is. V0 is the depth or height of the potential barrier, and B is the width. Dear students, if I increase V0 and keep on decreasing the B value, then I would like to use this condition that product of V0 and B must remain constant, finite. Then I shall get a Kronig delta function. as b tends to 0, v0 will tend to infinity. This approximation I would like to use. So this is what I have written here, that to solve this equation Kronig and Penny considered that potential function is a delta function, that when v0 tends to infinity, b tends to 0 and their product remains finite. In such a case, when b is tending to 0, sine hyperbolic beta b can be approximately written as beta b, because we know for small values of theta, sine theta is equal to theta and sine hyperbolic theta is also equal to theta. These are the approximations, and we know cos theta is nearly 1 when theta is very, very small. So dear students, once again I use sine hyperbolic beta b equals to beta b and cos beta b nearly 1. Then this equation can be rewritten. You can see I have put this beta b, so it will be beta square minus alpha square upon 2 alpha beta into beta b into sine alpha. This is not, it is as a coefficient of this sine alpha plus here one term cos hyperbolic beta b has become 1, so I am left with cos alpha is equal to cos ka plus b. Now this equation can be rewritten as a b square minus alpha square sine alpha. What I have done is I have multiplied by alpha a and divided by alpha a, the first term. So it is beta square minus alpha square, and 2 beta was already there, so I will get alpha a sine alpha a upon alpha a plus this term cos, and that is equal to cos ka. Writing b equal to 0, it is cos ka. So finally I shall call this value as p, capital P. I will use this as a parameter. Then p sin alpha upon alpha plus sin alpha equals to cos ka. This is what I will get. Here p I have written beta square minus alpha square, and this is ab by 2 into beta square minus alpha square, and we know what beta and alpha are. Alpha was 2me upon h cross square, so you can write down those values which I earlier told yesterday. Sine so I will be 2m v0 minus e upon h cross square. This is beta, this is alpha square, of course. So I shall be left with this simple expression, 2 ab m upon h cross square v0 minus 2e. And when we use this approximation, see that b tends to 0 and v0 tends to infinity, then v0 will be far, far greater than e. Here it is. So I can, v0 is far, far greater than, so p will be nearly ma upon h cross square v0 b. This is the value of p, and it is called, p has a, you can see this equation is called Kronig Penny equation. This is very important, and p has a simple physical interpretation that if p tends to 0, then E will be equal to h cross square k square upon 2m, which are representing the free particle solutions of energy. So P0 means the electron is free and it is not bound to any potential value. Then other values of P we shall discuss in the next lecture, that what other informations we can extract from this equation of Kronig Penny. Thank you.